Hello boys, welcome to the second lesson on differentiation. Now that you have understood what is differentiation, uh, you've understood what are standard derivatives, how to derive the formula of differentiation, how does difference derivative come into existence. So we need to proceed towards differentiating a function using the standard derivative. Okay, so for that we need to learn the rules of differentiation. So basically, how would you differentiate a function if it is given in a different format? Okay, so this is what we will do in today's class, and we will also solve some sums today. Okay, so this general rules of differentiation is to be copied in your notebook. So the first one is ddx of a. If you ever have ddx of a, let's say a is a constant. If a is a constant, then ddx of a constant is always how much, everyone? 0. You can justify this by saying that what is the rate of change of a constant when there is a change in x. For example, if y equals to 2, what will happen to y if there is a small change in x? Since y is not dependent on x, see, y equals to 2, y is always 2 whatever happens to x. That's why there is no change in y even if there is a change in x. That's why we say ddx of a constant will always be how much, everyone? 0. The second rule says ddx of ux, sorry, ddx of au, my mistake, au. If you ever have ddx of au where a is obviously constant and u is a function of x, u is a function of x, if you have this, then we write it as a will come out, the constants will come out of the differentiation sign, and we write du of dx. So a will come out, and whatever you get, the differentiation of u, you will write it down. So correct, everyone? The third one now. The third one is interesting. We say it the product rule. What do we call it, everyone? Oh, sorry, not the product rule, not this one, sorry. The third one, I would say ddx of u plus minus v. Okay, where both of these are functions of x, u and v are functions of x. What will you get if you ever have ddx of plus minus v? Anything, it can be either added or subtracted. Then we can distribute ddx to each of these here. It will go here as well as there. So you can write it as du dx individually plus minus dv dx. Did you see that? What happens? The differentiation symbol gets distributed. Okay, the fourth one is finally now the product rule. Okay, product rule. What is the product rule now? See, the word itself says product rule. We multiply. We will see how to differentiate a function when they are multiplied. Check this out. ddx of uv. If you ever have ddx of uv, then how do we write? We write it as let us say u is, okay, let me show you in different color. Let us consider u as first function and v as the second function. There is no particular rule to select the first and the second function. You can say anyone is first, anyone is second. Since u comes first here, I'm considering u as first function and v as the second later function. Okay, then we write v ddx of du by dx, that is a second. Did you see the pattern, everyone? Second ddx of first plus first dv by dx. Check this out, everyone. What happens? How to differentiate? This is very interesting. If you ever come across a product of a function, then how to do it? The second one comes out, then you will do ddx of first. Okay, then the first one comes out and you do ddx of second. So it's quite simple. Yes, one after the other. You just have to differentiate one after the other, taking one out. So first take the second out, do the ddx of first, then plus take the first out, do the ddx of second. Okay, I will show you all of these with an example now once I complete this rules. Okay, the fifth one is finally the quotient rule. Now this is the last one, quotient rule. Okay, the quotient rule means how to handle functions which are divided, like this u by v. This is v, by the way. Okay, so how to handle this? Now here what we do is if you ever have a u by v, then the rule will be same as the product rule, almost same as the product rule. So second will come out, v will come out, and you will do du by dx. Then the first one will come out u, and you will do dv by dx. Okay everyone, but the sign in the middle will be minus, remember. Also in the denominator it's followed by v square. Okay everyone, so how to write in terms of first and second? I will better, so if I say, if I okay, let me write in different color. If I consider u as first and v as second, then what do I write? Second ddx of first minus first ddx of a second divided by, it will be always second square, correct? So that's how the quotient rule works. So these are the 5 different rules of differentiation. I want you to copy this in your notebook. Now we are ready to solve some sums. Before we start actual sums on differentiation, let us now learn first to differentiate some of the powers of x. How would you differentiate it? Okay, so everyone knows what is ddx of x to the power n formula. The formula is nx to the power n minus 1. Remember, n will come front in as a coefficient, and the remaining power will reduce by 1, correct? So what will be ddx of x square if you ask me? So ddx of x square, here this 2 acts as n, isn't it everyone? So that will be 2x to the power 2 minus 1, that's 2x. What is ddx of next one is x to the power 3. This will be 3x to the power 3 minus 1. That's 3x square. What about ddx of, let me do something on my own, x to the power 4 then. 4x to the power 4 minus 1. That's 4x cube. Isn't it everyone? If you want to do it directly, so there will be a method now. Now if you ask me what is ddx of x5, ddx of x5, directly I can write 5x and 1 less, 4. What is ddx of x6? Be 6x and 1 less, 5. What is ddx of x to the power 10? I'll say 10x and 1 less, that's 9. Got it? So that's how the powers of x will work. What about the others that's here? Let's say, what about root x? Check this out. What about root x? Let's see how does root x work. ddx of root x. Now everyone knows root x means x to the power half. So ddx of x to the power half. So same thing again, half front, x to the power half minus 1. That's half x to the power minus half, that gives me 1 by 2, and x to the power half, because minus half comes down and becomes plus half, that gives me 1 by 2 root x. So you may write this, copy this down as a formula. ddx of root x is 1 by 2 root x. So you may not have to do it again and again and again later. Got it? Okay, next one would be ddx of x to the power 3 by 2. Let's see that. How does it work? 3 by 2. ddx of x to the power 3 by 2. That gives me 3 by 2 x to the power 3 by 2 minus 1. That's 3 by 2 x to the power, LCM is 2, then 1 by 2. So that's 3 by 2 root x. Got it? So that's how it works. What about the denominator powers of x? If you have powers of x in the denominator, let's see that as well. ddx of 1 by x cube. How to do this? ddx of x cube will come up, it will be x to the power minus 3. So minus 3 x to the power minus 3 minus 1. That's minus 3 x to the power minus 4. So minus 3 by x to the power 4. Did you understand this? I use the formula nx to the power n minus 1. Got it? So any powers of x, this formula. Any powers of x, you'll have to use the same formula. Got it? That's different powers of x. Let me discuss about applying product rule and quotient rule also a little. Okay, how to apply product rule and quotient rule. What is the product? What was the product rule? The product rule was ddx of uv. If you ever have uv, let's say you have x e to the power x. How to do this? What is ddx of x e to the power x? So remember, you need to separate the function. Let's say this is the first one and this is the second one. Then you need to apply how? Second into ddx of first. That was the formula, isn't it everyone? Second into ddx of first plus first into ddx of second. Wasn't that the formula everyone? You check out in your formula copy the general rules of differentiation. Or you may say v ddx of du by dx plus u dv by dx. That's also whatever. I better prefer saying first and second, that way it will be easy. Got it? So second is ex. ddx of first means x plus first is x. ddx of ex. So remember, just putting the values in place, second, first, second, like that. Okay, then what is ddx of x? 1, no need to write. Ex plus x. What is ddx of ex? Ex. So ex common, 1 plus x. So that will be the answer. So I'm just teaching you basics here, okay? I'm giving my own questions and making you understand how to apply quotient rule, product rule, okay? So again, if you have, instead of this, let's say, okay, let me rub all of this. What if you have x log x, just an example? Then x will be considered as first, this will be considered as second, and then the same thing, log x, that's the second one, ddx of first plus first is x into ddx of second, and then you continue. Got it? So this is how you apply the product rule. Next we go to the quotient rules. Quotient rule. How to apply the quotient rule? Quotient rule is of the type u by v, ddx of u by v. How to do this? So let's say, let me give an example. What about ddx of x by ex? Same example I'm giving you, okay? If you ever have this, then this can be treated as first and this can be treated as second. Same thing. And then what is the formula? Write down the formula. Second into ddx of first minus first into ddx of second, and then you have second square, isn't it? Check this out, the formula. If you want it in terms of uv, I'll write it here. V du by dx minus u dv by dx divided by v square. You have to mug up this formulas, remember. Then let's put it in place. Ex ddx of, what is the first? X minus x ddx of ex, and then I have e to the power x whole square. Simplify this. ddx of x is 1, so only ex. ddx of ex is ex, so I get x ex, and divided by ex whole square. Finally, ex common, 1 minus x divided by ex whole square. Square and one of the ex gets cancelled, so the answer is 1 minus x e to the power x. So that's how we apply the quotient rule. If you have, instead of this, another one, if you have let's say let me put it this way, if you have sine x by x, how to do this? Then same thing, consider this as first, consider this as second, and apply in the formula. So what will be the formula, by the way? Let me directly do it now. Second, first is second, okay? Yeah. So by the way, you have to write the second one first, I mean to say. So x ddx of sine x plus minus sine x ddx of x divided by x square, and then you can continue, okay? You just have to differentiate alternatively, one by one. X comes out, ddx of sine x, then sine x comes out, ddx of x, like that, okay? So that's how we put product rule and quotient rule into practice. Now we are going to start with some basic differentiation sums, and the first one is differentiate x to the power of 4 plus 4 to the power of x plus log x minus of 1. So let's start. How do you differentiate? First we need to apply the operator. So ddx of x to the power 4 plus 4 to the power x plus log x minus 1. So now you know from basic rules of differentiation, ddx can be distributed, isn't it? So I can individually do this. So I can write ddx of x to the power 4 individually plus ddx of 4 to the power x individually, and ddx of log x individually, ddx of log x. See, how am I distributing the ddx? Minus ddx of 1, isn't it? Now that I have distributed it, let's differentiate it individually. So this is, which form is this? This differentiation is of the form ddx of x to the power n. Doesn't it look like x to the power n? Because this 4 acts as n. Okay, so what is ddx of x to the power n? Nx to the power n minus 1. Remember that. Look at this. So the power will come front here, and then this will become n minus 1. That means 4x to the power 4 minus 1. Correct? Okay. Plus, what is ddx of 4 to the power x? This looks like okay, this looks like ddx of a to the power x, isn't it, everyone? ddx of a to the power x, because x is in the power and there is a constant here. So the formula is a to the power x log a, if you remember. Look at the standard derivative, isn't it? So that gives me 4 to the power x log of 4. And finally, what is ddx of log x? 1 by x, and ddx of 1 is 0, so you don't need to write that because 1 is constant, correct? Okay, so now this gives me 4x cube plus 4 to the power x log 4 plus 1 by x, and that's the answer for this sum. So I hope you have understood this. Let me quickly show you how to differentiate algebraic powers. For example, if you have ddx of x, it is 1. Everyone knows that. If you have ddx of x square, remember the sequence, okay? This 2 will come front and the power will be 1 less. So it will be like this. So ddx of x square will be 2x to the power 1. That's 2x. What about ddx of x cube? Check this out quickly. 3x square. 3 comes front and this will be 1 less. Got it? What about, okay, let me rub this. What about ddx of, okay, ddx of x to the power 4? It will be 4x and 3. What about ddx of x5? Did you see the sequence, everyone? 5x and 4. So this power will come front and this will become 1 less. Okay, the new power will become 1 less. So follow this sequence. So if I ask you what is ddx of x to the power 9, you should be directly be telling me 9x to the power of 8. ddx of x to the power 20, 20x to the power of 19, 1 less. Got it? So that's the first one. I hope you have understood this. Let's move to the second one now. The second one here is x square tan x. Let me do it with red color itself. So you have to differentiate x square tan x. Okay, maybe sometimes the question might be given like this also. You might be given y equals to x square tan x, find dy by dx. It is the same actually, even if it is given like this or simply x square tan x, it's not a problem. So how would you do if you simply have x square tan x? Let's say I had actually only x square tan x. So I will say ddx of x square of tan x. Isn't it, everyone? I'll apply the operator differentiating. Got it? Now what I need to do is look at this. I think there is a product of a function here. This is the first function, this is the second function. Doesn't it look like ddx of uv, everyone? Yes, because the product rule. Yes, I have to apply the product rule. How do you know I have to apply the product rule? Because the two functions are being multiplied here. And what was the rule? What was the product rule? If you remember, the product rule was second into ddx of first, if you remember, plus first into ddx of second. Isn't it, everyone? So that was the product rule, all in terms of uv. If you want to say, then v ddx of u first plus u du dv by dx, like this, isn't it? Okay, so that's how it works. Now, having understood the product rule, let's apply it here. I'll rub this here, so I'll not rub this rule. Okay, so follow this. So second is tan x into ddx of first, means x square, plus first is x square into ddx of tan x. Okay, so let me show you again with a different here. So this is first, by the way, and this is second. Okay, so that's why you see here second ddx of first plus first ddx of second. I have done that. Check this out. Did you understand? See this? Yes, wherever is second I put tan x, wherever is first I put x square. Correct? So that gives me now tan x, that's not a problem, into ddx of x square. Make sure you put bracket, is 2x. Correct? Plus x square. What is ddx of tan x? Look at the standard. How do I know this? By the way, I am following the standard derivative. What is the ddx tan x? Look at the standard formula. ddx of tan x is sec square x. Isn't it? So finally I have, it's better to write this 2x right in front, 2x tan x plus x square sec square x. So that's the answer for the derivative of x square tan x. Make no mistake, make sure you write 2x right in front only, otherwise you will make mistake of multiplying these two, which is not correct actually. You can't multiply this x with this 2x. Okay, remember that this 2x is a separate algebraic function. You need to write it right in front here. Okay, so that's the second one. Okay, now let's go to the third one. The third one, here we have x square ex log of x. Okay, let me do it with green color itself. So how would you do this? So ddx, first I need to apply the operator x square ex and log x. So here I see there are three things multiplied together, isn't it, everyone? Check this out. Yes, so there are three functions multiplied together. I don't have a rule for three functions multiplied together. So what will I do is I will do two at a time. So I will consider something like this. Check this out. I will consider this as first and this as second. Correct, everyone? So let's apply the rule. The rule says a first into ddx of, sorry, not this one, second. The rule is product rule. Are you following the product rule? Second into ddx of first plus first into ddx of second. Isn't that the product rule. You may not write this, I'm just showing you to writing this to for you to understand. Okay, so let's put it in the values in place. That will give me log x and ddx of what was the first one, x square ex, and first is x square ex, and I have ddx of second means ddx of log x. Correct everyone? Check this out. Now this gives me log x ddx of e to the power x, and see, now this I can't evaluate. Again, did you see it here? So if even inside this, if you see carefully, even inside here, I have again a product rule inside the product rule. So product rule inside the product rule, you can say that, isn't it? So how do I handle this? Open a bracket, again use product rule. Now here this will become my first and this will become my second. Remember that. So same logic, second into ddx of first plus first into ddx of a second. Is that clear everyone? Plus x square ex, and what is ddx of log x? 1 by x. So x and 1 of the power gets cancelled. So I have log x. Let's evaluate this. ddx of x square is 2x, which I will write right in front, e to the power x, plus this ddx of ex, so x square ex, and finally I have here x e to the power x. So mix it up, I get 2x ex log x plus x square ex log x plus x e to the power x, and that's the answer. You could have taken ex common as well, so that doesn't matter here. So did you understand everyone? So this is how you will do. This one was quite a tricky one. Make sure you understand it properly. First, there was 3 functions together. I have taken 2 at a time, so I've combined them and made first function, this as a second function. Then inside the product rule there was one more product rule which I had to apply, and I got the answer. The fifth sum, differentiate x square plus x cube plus x square plus 1 and sine x. So you might think about breaking the bracket. Let me tell you, it's good to differentiate without breaking the bracket, considering this as a product function. Doesn't it look like a product function everyone? This looks like a first function and this looks like the second function, isn't it everyone? Okay, so let's continue with the formula. So it will be second into ddx of first, by the way, that's the formula, plus first into ddx of a second. So just for your understanding, I'm writing this. You may not write this. So that gives me sine x ddx of x cube plus x square plus 1 and x cube plus x square plus 1 and ddx of sine x finally, isn't it? Okay, now let's do it. So sine x, directly, we are not going to distribute this individually, okay? Directly, what is ddx of x cube? 3x square, if you remember. 3 front, power will reduce to 1. What is ddx of x square? 2x. What is ddx of 1? That's constant, 0. No need to write. Plus x cube plus x square plus 1. And what is ddx of sine x, everyone? Cos of x, isn't it? Okay, look at the standard formula. So that gives me finally 3x square plus 2x sine x plus x cube plus x square plus 1 cos x. So no need to open the bracket, that will be enough. Correct? Okay, and finally the last one for today, and that is differentiate x tan x. Let me write here, differentiate, by the way, x tan x divided by sec x plus tan x. So a little difficult one here. How would you start? So let me start by saying ddx of x tan x. Let's apply the operator first, sec x plus tan x. I apply ddx, the operator, differential operator. Now doesn't it look like u by v, everyone? Yes, u by v. So I can say this first, I can say this second. What is the formula of u by v? Second into ddx of first minus first into ddx of second divided by second square. Isn't this the formula? Look at the general rules of differentiation. Now I need to apply the function. So second is sec x plus tan x. Carefully, ddx of first is ddx of x tan x. Look at this carefully. Here I will have to apply product rule later again, because x and tan x is being multiplied together, isn't it? Okay, minus first is x tan x and ddx of sec x plus tan x, correct? Whatever is the first and the second, putting the values in place, divided by sec x plus tan x whole square, correct? Okay, now let me rub this side for the previous sum. Okay, now comes sec x plus tan x. I need some space, so I'm starting right from towards my left. What is ddx of x tan x? Again, product rule. Did I not tell you that? Product rule. So here again I need to do something like this. I'm going to do in red color. This acts as first and this acts as second. You are already aware of the product rule. So second is tan x into ddx of x. That's the first one. Plus first, that's x, into ddx of second one, tan x. Okay, close the bracket, minus x tan x, and let me do this. What is ddx of a sec x? ddx of sec x is sec x tan x. What is ddx of tan x? Sec square x. So carefully look at this. I hope you've understood this. ddx of a sec x is sec x tan x. ddx of tan x is sec square x. Where? From the standard derivative, correct? Whole divided by sec x plus tan x whole square, correct? Okay, so now let's simplify this further. Let me do it black again. So sec x plus tan x, check this out. And what is ddx of x here? 1, no need to write, so tan x, plus what is ddx of tan x? Sec square x, so x sec square x, close the bracket, minus I think okay, let me just keep it as it is, x tan x divided by sec x tan x plus sec square x. Okay, and whole divided by sec x plus tan x whole square. Now let me rub this. I need some space up here. Okay, so how would you simplify this one now? So if you see here, check this out, let me show you with the highlighter. If you see here, I can take out especially here, I can take out sec x common from the bracket, isn't it? So let's do that. So I'll keep the first one as it is, sec x plus tan x, open close bracket. Then I have here tan x plus x sec square x, and then minus x. I can take out here, check this out, sec x common, so take out tan x is already present, sec x will be common. So what's left inside the bracket? Tan x plus sec x, correct? Whole divided by sec x plus tan x whole square. Okay, now if you see, sec x plus tan x is here, sec x plus tan x is here as well. So can I take them common? So sec x plus tan x common, and left with the big bracket tan x plus x sec square x minus x tan x and sec of x. So divided by sec x plus tan x whole square. So the square and one of the factor gets cancelled. Let me rub this now. And finally, I just need to write the simplified version of this statement. So I'll get tan x plus x sec square x plus x tan x sec x, and whole divided by sec x plus tan x. So I think that's my answer, because that's how much I can simplify. So if you ask me now how to know where to simplify, where to leave the answer, can we not leave the answer here? Some of you will ask me, okay, we'll have a question later. So my answer to that question would be simplify as much as you can, because if you oversimplify, your marks will not be deducted. If you undersimplify, your marks will be deducted, remember that. So as much as you can, you just simplify and leave the answer till there. So that would be my answer, because that's what I can do to this function, correct? So that much for today. So thank you.